We're going to look at solving equations using nth roots and also some properties of rational exponents. Let's say we have an equation like 2x to the fourth equals 162. If you want to solve an equation that has an exponent like this, and you only have two items in the equation, what you want to do is get the thing that has the exponent by itself on one side. And so right now we have 2x to the fourth. We want to just have x to the fourth. So I'm going to divide both sides by 2. And then I get x to the fourth equals 81. Now I need to take the fourth root of both sides. And the reason I do that is here I had x to the fourth. I want to find out what x is. So I want to take the inverse operation of raising to the fourth. The inverse operation of raising to the fourth is taking the fourth root. So the fourth root of x to the fourth is just x. The fourth root of 81 is the number that when multiplied by itself 4 times gives you 81. And that number is plus or minus 3. Remember, when you're taking the even root of a number, you have two answers, the plus and minus of that answer. That happens when you take the even root. Okay, let's look at another one. Here I have x minus 2 to the third equals 10. Now, I don't want to multiply all this out because that'll give me something pretty difficult to solve. But since I have something on this side raised to a power and just one thing on this side, then I can just take roots to get the answer. This is raised to the third power, so I want to undo raising to the third power, and undoing raising to the third power is taking the third root. So the third root of x minus 2 to the third is just x minus 2. And that's going to equal the third root of 10. Now, the third root of 10 is not an integer. There's no integer that when I multiply by itself 3 times, I get 10. So if I want to, I can just leave it like this, or I can find out what it is as a decimal or an approximation of it. So I'm going to take the third root. Now, there actually is a third root button here. That's number 4. And I can use that. I could also use this xth root and tell it to take the third root, but I'll take the third root. And I wanted the third root of 10. So the third root of 10 is 2.15444. So I'm just going to use 2.15. And so x minus 2 equals 2.15. Approximately. Now to get x, I'll add 2 to both sides, and I get x equals 4.15. Notice that when I took the third root here, I did not put plus or minus, because when you take the odd root, you don't have to do plus or minus. There's just one answer. If this number had been negative, there would be a negative answer. Since it's positive, there's a positive answer. Okay, now let's look at some properties of rational exponents. The properties are very similar to the properties you already know about exponents. That when you multiply, you add exponents. When you raise a power to a power, you multiply exponents. Let's look at some examples. Let's say I have 5 to the 1/2 times 5 to the 1/4. Here I'm multiplying. Because I have the same base, my answer is going to be 5. I just leave that alone, and my exponents add. So 5 to the 1/2 plus 5 to the 1/4. 1/2 plus 1/4 is 3/4. So this is 5 to the 3/4. And that's my answer, or I could evaluate it on a calculator. Okay, now let's look at another one. Let's say I have 8 to the 1/2 times 5 to the 1/3 raised to the second power. Now, I can't multiply these the way I did the 5s because they don't have the same base. Now, this is a multiplication sign, and so that means I can apply this square to both of these items. If I'd had a plus, I'd have to FOIL it out. But with the multiplication sign, I can just apply that square to both of them. So this will be 8 to the 1/2 squared plus 5 to the 1/3 squared. Now when I raise a power to a power, I multiply exponents. So 8, 1/2 times 2 is 1, so 8 to the 1st, plus 5, 1/3 times 2. Remember how you multiply fractions, 1/3 times 2 over 1. You multiply the numerators, multiply the denominators. 5 to the 2/3. 8 to the 1st is just 8, so this is 8 plus 5 to the 2/3. Now this is nothing that I can simplify easily, because this would mean take the third root and raise it to the second power. Well, the third root of 5 is not something even, and so I'm just going to leave it like that. I'm sorry, this should be times, not multiply. Times, 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 times. So, sorry, times, sorry. Okay, all right. All right, now let's look at another one. So I have 2 to the 4th times 3 to the 4th raised to the -1/4. Okay, again, multiplied, so I can just apply this to each of these and multiply my answers. And so this will be 2 to the 4th times -1/4 times 3 to the 4th times -1/4. Alright, 4 times -1/4 is -1. So this is 2 to the -1 times 3 to the -1. Now remember what a negative exponent means. It doesn't make this negative at all. It means I take it to the denominator. So this becomes 1/2 times 1/3. Now, really this is 1 over 2 to the first power times 1 over 3 to the first power because of that 1. But 2 to the first power is just 2, and 3 to the first power is just 3. So this becomes 1/6, and that's my answer. Okay, let's look at another one. Okay, now I'm going to take 7 over 7 to the 1/3 and figure out what that is. Okay, this is the same as 7 to the 1st over 7 to the 1/3. 1 is bigger than 1/3, so I'm going to subtract 1/3 from 1, because remember when you divide, you subtract exponents. So this will be 7 to the 1 minus 1/3. Now it's in the numerator because the 1 is bigger than the 1/3. And so this now becomes 1 minus 1/3 is 2/3, so 7 to the 2/3. Now if I had had it the other way, if I had had 7 to the 1/3 over 7, I would have written it like this, 1 over 7 to the 1st minus 1/3, because this 1 would be bigger than the 1/3, so my answer would be here in the denominator, and this would be 1 over 7 to the 2/3. Alright, now I'm going to take 12 to the 1/3 over 4 to the 1/3 and raise that to the second power. Now when I look at this, I can't do what I did with the 7s because these are different numbers. But I do realize that both of these are raised to the 1/3 power. And I recognize that 12 is divisible by 4. So I think I'm going to get something easier if instead I write it as 12 over 4 to the 1/3 and that whole thing squared. Notice this is the same as this because this is 12 to the 1/3 over 4 to the 1/3. Now 12 is divisible by 4, so that gives me 3. So now I have 3 to the 1/3 squared. And when I raise a power to a power, I multiply exponents, and so I get 3 to the 2/3. Alright, let's look at another kind. This time I'm going to take the third root of 4 times the third root of 16. Now, as written, I can't multiply these because well, I could multiply them, and so I will. There's another way I could do this, but you can multiply the things on the inside times themselves and things on the outside times themselves. So I can now rewrite this as the third root of 64. And then I can ask myself if I know the third root of 64, and I do, but in case I want some help with it, I can do, there's several ways you can do this on the calculator. You can take the third root by pressing 3, and then math, and then the xth root, 3, math, xth root of 64, and no parentheses, and that gives me 4. Another way I can do it is, since the third root is the same as raising to the 1/3 power, I can raise 64 to the 1/3. Notice I put the 1/3 in parentheses because order of operations says raise to a power before you divide, and I would need to divide first. So that also gives me 4. So the third root of 64 is 4. So this gives me 4. Okay, let's look at another one. Let's say I have the fourth root of 162 over the fourth root of 2. Since these are the same, since these are both fourth roots, I can just divide this 162 into 2. The same was true up here. Because they were both third roots, I could multiply. If they hadn't been the same root, I couldn't do it. So this then becomes the fourth root of 162 over 2, which is the fourth root of 81, which is 3. Okay, so that's that.